see how this goes. There we go. Okay, so my name is Heather Lewin. I am the NCBI expert, I guess, at the library, as much of an expert as we have. My background is biochemistry. I have an undergraduate degree in biochemistry, and I worked for a year doing cell signaling research for diabetes. So I speak the language kind of, but it's kind of rusty because it's been about 10 years since I've been in a lab. Last year, this time, I spent 6 weeks doing an in-depth class on NCBI, and then I spent a week out at NIH headquarters in Bethesda with a hands-on class. So I understand kind of what goes on. I can direct you to where you need to be and tell you it, but I can't figure out your question for you. I don't speak science well enough anymore to really be able to tell you if the results you're getting are good results, but I can tell you how to get decent results. So just putting that expectation out there for you. Today we're going to be covering how to really personalize the website so that it tracks what you do, and you can set up an account, and so that you can make sure that the results show up the way that you want it to. Those types of things, and so that you can know some of the kind of cool functionality that's available for you. It's a small group. I expect that if you have questions, you just let me know. I do that anyways, but I tend to think and talk faster than I ought to at times because I've done this a couple of times now and I'm familiar with the website. I anticipate that other people follow along. If I have gone too fast or you miss something or I say something and it just doesn't register because you're working on something, let me know and I can slow down and backtrack and re-show you how to do it. So NCBI, you should all be able to get to this site. You're all there? Awesome. Okay. So what we're going to be doing is setting up an account. Do any of you currently have an NCBI account? No. Okay. So anybody can create an NCBI account. You just have to go to the NCBI database page at ncbi.nlm.nih.gov, and then click on this sign into NCBI on the top right-hand corner. And you can create an account. You can create an account if you are a grant holder. You can create an account if you're an NIH worker, or you can just create a random account for whatever you want. You can link it to the university here if you want to. If you intend to go and keep this account, I wouldn't recommend signing in via Iowa State because you want your account to be kind of separate than that. So if you wanted to link it there, you can do that. I would recommend just setting up an account, not using Google or any of that kind of stuff. Just go for an account since none of you are grant holders. Start that way. Choose a username and a password, something that you can remember. And I'm going to give you some time to get that set up. It shouldn't take very long. I'm going to do some wandering around. So you need to register for an NCBI account.
Oh, here?
Yep. Yep. Okay. I signed in because, here. This will help. Here, let's do this. Now you can see what I'm doing. I forgot about that aspect. Here, let's do this. Now you can see my screen rather than me having to tell you where everything's at. Now you can see it. Lovely. I thought they were already on. So on that sign-in page, it says if you don't have an account, you're going to create an account. It's one of the lower options.
Why is it saying like this account name is currently unavailable?
That means that somebody else in the world has decided that that's what their account name is.
So do they have to pick something different?
Yep.
Yeah, okay.
Yep. Because it's open to anybody. Anybody in the world can have an account name. And it's going to ask you some basic information and connect it to your email and do all sorts of fun things. So takes a minute to fill in the form. If you want, at this point, to link it to the Iowa State University, there is an option to do that in the corner. It means that when you go to PubMed and you're logged in, the Get It at ISU icon is going to be there throughout PubMed. So if you're doing a literature search, it will link you back to the university's library to see if we have the full text of things. So that's a good benefit of doing it from here. You don't have to if you don't want to, but it is an option. Nice, we're good. You've got an account, you've got an account, you've got an account. Awesome. Now we're going to go take this a step at a time. So on your page, on your NCBI page, if you go back there and you're signed in, it should have your sign-in name up at the top along with my NCBI and then a sign out. If you click on your name, it gives you a list of where you can change your security question or your password, who else, what your email is, who you're associated to or with, if you were working on a grant, who else can work on your account. And then it's got this site preferences page, which I really enjoy because it makes me happy. So if you click on that, it gives you an options for all of the things that you can change about your account and how it looks. So this goes from everything. So common preferences are things like, okay. So in this link, the HS Lewin link, or whatever your account name link is, there is an NCBI site preferences. And this is how I've set up mine. You can do however you want. My links I'll display as plain text instead of having to click over something and have a drop-down box. When you click on these options, it will show you what the differences are. So I don't want a pop-up menu. If there's an option to click on something else, I want it in plain text. If you like the pop-up menu and your computer runs JavaScript really well, opt for that way. When I do a search for something, I want my words highlighted in, and I chose a particular color. You can choose bold, you can choose nothing, you can choose whatever color is really your favorite. There are standard sets, but this is kind of what it is. When you do something like search in PubMed, I have a particular way that I like to show it. You can change those later on. So as you learn what your preferences are, and I'll show you where you can see the preferences in the different databases, like you can change the view while you're in the database, but if you go to a database over and over and you're like, oh, I really like this view better, you can come here and change that view without having to change it every time. And so this is where you really personalize how you like to see it and do that kind of stuff. So I am going to refer really quickly to filters and icons under PubMed. So if you click on that one in particular, and you can do this from other locations, I just find it that I remember it best from here. So when you're searching for literature in your subject area and you're finding, oh, I always have to limit it to humans or things that are review articles or in English or whatever options you want, there are standard limiters here that you can see, and then you can click and choose which of them you want. I wouldn't recommend free full text or full text because we can get you anything at the library, but those are options. I teach a lot of undergrads, and so published within the last 5 years is a lot of times a thing that their instructors want for teaching purposes. So I have that, and review articles are my filters. When I go to PubMed, if you want to create a custom filter, if one of these filter doesn't work, there's popular ones, there's links out. If you want the results in PubMed to link to something else, you can create those. If you have a particular property you want it to have, if you're doing a clinical thing or a particular organism, you can do that, and then links within different databases, you can do that as well. So in PubMed, my PubMed, PubMed is there. When I do a search for, let's do stem cells. I get an autofill. My filters are over here. So if I automatically want to know, oh, which of these has a link in the record to gene, I just click this and it automatically filters my results for me. So it's really nice to set up your filters if you know what you're studying already and you know that you're going to be doing the same type of search over and over again and going to filter it the same way. Start here, set up your filters ahead of time rather than having to go here. On this side there are filters. How did I filter from PubMed? I did my search, and then your filters are over here. They're going to show up on that side. So whatever you search up on your search bar, you'll get a results page that looks like this, maybe. And then your filters are going to be over on your right-hand side. Yep, the ones that you choose will be over there. There are other filters available, and those are going to be on the left-hand side. And you can show more filters if you really want to. I chose these particular ones because, again, these are what most of the undergrad students are interested in. On the customization page where it said the different customizations, I personally have chosen for summary, which is just the title and the other information. You can change that. And here's a really easy way to look at like kind of what it looks like when you change them. It is thinking because it takes a lot of time because I have a lot of results that show up on a page. Let's limit this, and then, so if you choose abstract instead of summary, you're actually going to see the abstract of the paper and some information and keywords and public mesh terms and all sorts of things show up in your results page rather than just that little one line. It depends really on how you want to view it. If you like the big abstract, instead of having to click in and see what the abstract is and then come back to your results, you can set it in your setups and your setup page to look like this all the time without having to change it. And then how it shows up, if you want the most recently published things on top, you can switch that as well. So this is let's go back to, I'm too many clicks back and it doesn't like when you go through them backwards. So on this page, when you're changing these things, it's changing how your results look when you go to a page. And you can change it for gene, you can change it for nucleotide, you can change it for protein. ClinVar. All of these things have different ways of showing your results. So this is your preferences. If you find yourself changing things all the time, come back to your preferences and set it that way. But, okay. I'm going to go to the My NCBI tab then. Mine looks different than yours because it's got this lovely feature of being able to drag and drop things, which makes me very happy. If I want this over here instead, I can drag and drop it. It's lovely. It does keep track when you're signed on. It keeps track of everything you've done so that if you forget, I think it's a week. I'm not really sure, but about a week it keeps track of things until it runs out of space. And it keeps track of about 10, I want to say. Yeah, 10 things that you've searched, the last 10. So you can see what you've searched, and if you want to go back, oh, I found that paper doing this search, click back through that way. So that's what your recent activity is. You can turn it off or clear it. If you searched for something and it just didn't work, you can clear your history and then it's fine. The My Bibliography I'll get into. I actually published this paper. That's why it's under My Bibliography. The My Bibliography is not papers I'm putting in to be a part of a bibliography. It's actually your papers. It's a huge distinction because NCBI looks at that when they're looking at grants as to what your bibliography is. So if you have 1,000 things in there and you've published none of them, it's really ugly. So just you can do favorites. You can create collections if you want to have a specific collection for a group that you're looking at. You can change your filters from this page as well. If you don't want to manage all of your preferences, you just want to manage your filters, you can do that. You can reduce them. So if you don't want to look at something, you can reduce it. Your collections are here. So if I have 2 articles here, I can go back and review them. I don't know if you need a science CV. People applying for grants in NIH and NSF have to create a CV to be submitted for grants using this program called the Science CV, and it pulls your documents that you've published from your My Bibliography. So having them correctly attributed is very useful. Okay. The other great thing that NCBI does through here is save searches. I've done these searches before. They look like this. They're in each place that you do a search. You can save your search or send to. When you do a send to, you can send to file, you can send to collections, you can send to clipboard. If you send it to your collections, it does that search. These things go to your collections. So this is a search I've done. I saved it last year. These are ones I did last year. It tells you what the new documents are from the last time that you saved it. It's very nice. And then you can manage your saved searches as well. So it goes through every database. Every database can do saved searches. You can manage them. It can see when you last searched it. And the great thing about this is, so you do a search in BLAST, or you do a search in gene, you do a search in protein, and you don't want to have to redo it over and over. You just want to see if anything gets updated on it, or if something else gets reported on a particular gene that you're working on, or a particular organism that you're working with. You can automatically schedule updates. So if I wanted to get an email about new things in the field at a particular time, I can set this so that every time new things come, they collate, and then I can set how often I want those updates to come to me. So if it's a publication or a gene or a protein or whatever, you can have those updates sent to you monthly, weekly, daily, which day if you're doing monthly. If it's daily, obviously it's going to be all the time. You can do, it does that summary versus abstract again. So either that one-line sentence that's just title of the article, the authors and where it comes from, or a full abstract. And then you can set how many things you want. Okay, now where did I want that to save from? I just save to, I think it's clipboard. I think file. Honestly, I have just lost it. It is someplace and it's very not obvious. I don't know why it's not obvious. I'll figure it out in just a second. It used to be in the send to thing. Okay, let's go back. I'll do a search and we'll figure this out. Add to, yes. Save. Well, you can do it at that level and you can do it at a higher level. Not just at a record level, you can do it at a search level.
So where are you now?
Okay, I'll go back. We'll figure out where we can save at and then go forward from there because that's a super important step. And where did I find my search? Create alert. So under your search at the top of the screen, it says create alert. So when you click on that, it gives you the name of your search, what the search terms were, if you want an update. So it's up here at the very top of your page, which doesn't make sense. And it moves often. At least it used to be over here in the send to, but now it's up here. So create alert, and you can find that. And it should be on all of your pages. Let's see. So I went to, okay, I jumped again. Okay, so I went to NCBI. Just if you click on this NCBI logo up in the top left corner, it gives you back to this main NCBI page. This is the place, this is like the landing pad for everything. A lot of people come here and they click on Blast and they never do anything else. But you can search a topic through all of the databases. It is not powerful. You're much better figuring out things one at a time if your search is complex. But if you have a simple search, you can see these are all the different databases that are available and how much is in each of those types of things. So if you go to, and it tells you what's in them, which is always a good reminder if you're searching for something and you're like, oh, I need the high throughput DNA RNA sequencing. You go to SRA. It gives you a brief description of what's in that database so that you can kind of figure out where you need to go. So if you can't remember where you need to go, just do a generalized search and find your database. But in things like gene, you can create an alert. It's in the same place. You can also change how this page looks from tabular to summary to XML to a lot of different things. And so it looks a little different in each of them. It gives you a little bit different information. Additionally, when you click on this, you can change the format here as well, and it gives you different information. So if you want a gene table instead of the full report, you get a gene table. So this is a really nice thing to remember, that if you only want a particular part, or if you want a summary, or you want a tabular version, you can change the outlook of it pretty simply. Those are like super basic, and I went through it really fast. Do you want me to continue to give you examples? Do you want me to let you play for a little while? Do you want me to show you how the things interact? Do you understand how NCBI is set up, first of all? I probably should have asked that question from the very beginning. Okay. We'll go back. So NCBI is based all around the central dogma of science, so of life sciences, that you've got DNA to an RNA to proteins. And so their databases are set up around those concepts. So gene is all about genetic information. Nucleotide is all about your sequences, and it goes together with that. And then you've got your proteins, and those are all grouped together. And then they kind of flow in together. So you can link from one to the other database really easily. They give different information, but it's all based, if you think about that when you're thinking about where to search for something, it will give you a little bit better view of things. Gene is your most broad database. I'm blanking on a gene. Tax. So if you do a search for gene, you're looking at a particular gene sequence. And it gives you where it's at and how it's being expressed, which pieces are being expressed, which are the exons and which are the introns. So this is a standardized version. The NC is a standardized version of this gene. The ones down here are interactions. NPs are proposed, are ones that are experimental. NCs are ones that are reference, that somebody has, at NCBI, has gone through and standardized. So they take a look at all the sequence that have been submitted for that particular gene, and they standardize it. They look at a reference assembly of that gene in that organism and say, oh, this particular gene is located here in the genome, and this is its sequence as far as we can tell. So that's what this thing is. It's a location within a particular sequence. They do change the reference assembly occasionally. I think they're in version 22 or 32. It's been a couple of times. So they put together a sequence of the entire organism. They're through, I don't even know how many different organisms. You can look in the taxonomy section and they'll outline which organisms have a full reference sequence for their DNA setup. And then you can look at it that way. Sure.
They correspond to these ones, or this is just this?
This is tax, this is rex, this is ingben. There are a bunch of different genes, but this piece is a piece these are the pieces being expressed, the solid pieces.
And then these are the introns?
Yeah, the spaces in between are the introns. Yep. So, if you can learn to read their gobbledygook, and it kind of looks like craziness, when you start, you'll be better off to figure out how things are being displayed. GenBank is where you submit things. So when you run a sequence and you find a new gene, or you're working on something bacterial and you find a new bacteria and you submit it to GenBank, you can click from gene to GenBank. This is the reference sequence. It's actually got the sequence. You can run BLAST from here. I think, yeah, you can run BLAST, you can pick primers, all from, this is now a nucleotide, we've switched databases. You can switch databases really easily. It's very easy to spot where you're at by going back up to this top gray bar. It tells you where you've been, where you're going. Okay. So this is the GenBank. You can do FASTA if you want that output, if you don't want the numbers included. It's a little bit easier to run. On each of the pages on the side, it links out to either external resources, related information in internal sources, internal to NCBI, and then recent activity, so that if you get really mucked up and you don't know where you've been or where you're at, you can just always hop back to someplace else. And most of the big reports in gene, nucleotide, protein all have these big tables contents areas in the full report, so that if you only want to, here's your ref seeks. If you only want to see the ref seeks, you can click on that and it will take you automatically to those. Okay. We're going to go back to NCBI really fast. NCBI. Okay, the ones on these resources on the right are the ones that are used most often. They're put there by number of people that have hit on that in a particular region. So these sometimes change, but this is most often what is being used. If you need to submit data, there's a big thing that says submit. If you are doing, I don't think any of you are doing bioinformatics, are you? Okay, then you probably won't download anything ever, but you can do that, like mass dump and then manipulate. If you want to learn more about a particular thing, or specifically about NCBI, they have helpful documents and tutorials beyond here. If you want to develop ways to search, if you want to use tools and you don't know which tools are available, analyze, and then this research is what they're doing, not what you're doing. These things on the side are all areas. So if you're looking for literature, this literature one is very nice. It tells you all the places you can get literature. It tells you how you can download it. It tells you how you can submit, and then it gives you extra tools in case you really need to know extra tools. I personally, because I'm an info junkie, I like information, I love the link out one. So you're working, I don't know if there's a database. Is there a separate database for soybeans? Like that instead of just soy base? Okay. So I clicked on this link outs. Let's see if they're the soy base one. Link out provider. Let's find Control F. Find soy base. Nope. Phytosome? Okay. PH or F? PHY. Nope. They're not linked yet. They are continually adding other databases. These are all databases and things that link to their systems. And you can see where it's linked. So if you're doing mouse genetics, or if you're doing something like fly genetics, you can link that to your research. And you can search by information that's linked to this database. So I would check every once in a while just to make sure that if you have a database in your area that you know that all of my information gets deposited here. Check and see because you can search PubMed to find papers that have data linked in a particular database. or you can search gene for things that are linked in flybase. And if you're doing flies, then it saves you a lot of time. Okay, are there any big questions about any of this so far? It's kind of a lot to get, it's really overwhelming, and I understand that. And I'm getting some confused looks.
So where did you go for links?
For links,
Yeah.
okay. So for literature, under literature, there is a tools section at the bottom that says link out. And when you click on it, it
So if I have to submit my database,
if you have to submit your data to here, you are going to be doing, if I can type NCBI, if you submit your data, you're going to submit here. So you would click on this. You can submit, figure out where to start. Try this. This is all of NCBI's stuff. If you have to submit here for your NIH grant or for your publication, this is where you're submitting your data at. So you make your selection of which thing you're going to, where it's going to end up, and then
if I have a sequence data and then I have to submit a sequence data.
if you have a sequence that you have to submit, yeah, you would go here. It would end up in GenBank, and then it would go into gene and protein. So, and if you don't know where your information is supposed to go, Submission Wizard will help you. Is there any parts of, I can't blast without a sequence. Let's try, how many, do you all use blast regularly? Sometimes? You do it, okay. Are you comfortable with, do you have to pre-select, do you use just the pre-selected standards, or are you changing, you just hit blast? Just put it in push go, okay. Do you want me to talk about how to make that searching better? Okay. I'm going to find a gene first because I don't have a sequence off the top of my head, and making one up is ridiculously impossible. So first find a sequence. Where did my gene go? Gene, there we go. So we're going to find a sequence and then blast it. Where are my RefSeeks? RefSeek. Fast. Okay. So I can run a blast on this. So I'm just going to hit run blast because I found my sequence. I want to run it. So it's going to look like this when I run. And then since I'm running from I'm doing a nucleotide sequence, I'm doing a blast N. You can choose a file, you can choose a query. So this is the reference sequence, and it's in this range. I'm doing nucleotide. I'm choosing which database it's coming from. I can choose an organism if I want to. I'm not going to because I just don't want to do that. You can do how optimized you want to do it. And then there's these algorithm parameters that probably, if you haven't selected them before, these are how it's running, like how it's choosing to match things. So right now, the target sequence is about 100 nucleotides to display that it's matching. You expect a threshold of 10. You've got to match. The word size is its specificity. So if you're given 28 nucleotides in a row that match, then the sequence will match. If you don't have 28 that match exactly, your sequence won't match. And by exactly, they mean exactly. Like, if you searched for your name and it was misspelled, it wouldn't match. That's how exactly it is. So they're looking at word size. You can change the word size up or down. The more specific it is, the less hits you're going to get. You can have a mismatch score. You can have gap cost, how much extension existence is there. We're doing linear because we don't want gaps in our thing. You can filter from a specific species if you really want that, or a low complexity region. So yeah. The other thing you can do, where did it go? It's not in this one, it's in the other one. It's in the blast piece. So, so when you run your blast, you get this blast. Yay! And this one's very easy because there's taxes in pretty much everything. That's T-cell lymphomic virus, and there's like 1 billion of them, of different variants. And they're all in there because every time they discover something, they've got to rerun it. So you can do a search summary that tells you how well you did, that gives you your information on how well it did and your length adjustments and how effective it was. These are all very effective. They're also clickable, so you can jump right to it. It shows you this display of how these show up is adjustable as well. If you haven't adjusted those before, you have formatting options at the top. So you can change from pairwise with dots for identity to pairwise to flat query. The thing I learned when I did my training was don't be afraid to click on something and see what happens. It's not going to break anything. Nothing will explode. At most, you'll wonder what happened, and at best, you'll find out something that's really cool. So, yeah. And you can choose how you're doing it. So X for proteins with N for nucleotide. You can do colors if you want it to show up. You can get rid of the graphical overview. You can get rid of the sequence retrieval. You can have the description be shorter. Like, it's all sorts of different things. But this is the start. And there's a lot of options here that you can do. You can also limit to, you can do taxonomy reports of like what these things all fall into, and then distance tree of results, which is this really ugly thing, of how close it is related to other things. Distance tree of results. So it will show you, since this is a virus and it lives in viruses, this tree is pretty short. This is assumed. And a max, like neighbor joining, you can change, as I said, you can change it however you want, but this is a tree of where your results fit in, basically, for your blast search. It's not perfect. There are other trees that are better, but this is a really good initial tree. You can get them really ugly. If you've used this before, you realize that red is nice, and it gets worse as you get down the colors. It's less of a match. And if you've noticed this, when you scroll down, it shows you what this line at the top, this line here, changes as you scroll down the results. Okay, we're going to go back to BLAST. BLAST. So the BLAST homepage, if you're not getting there from within NCBI, looks like this. You can blast proteins, nucleotides, blast X, which is proteins translated. So protein blast uses protein as its thing, as its main way to go, and then blast X uses what they assume are going to be based on what the nucleotide structure is. So blast protein is looking at what are submitted basically results, and blast X is kind of potential possible results as far as I can remember. And then you can do specialized ones which get really ucky really fast and I can't really explain them. You can do psi and phi and make organizations. So you can switch between them here. This is for proteins. You'd have to have your amino acid sequence, and you can do your algorithms down here as well. You can select how big you want it to be, what your target sequence is. The smaller this is, the less likely you are to actually find good matches. So when you change things and you're in your thing, or even if at a computer that's being used regularly, when you change your BLAST settings, it stays. So if you've done a search and you've limited it to just soybeans and you come back and you do a search and you're not looking for things that are in soybeans, it still defaults to just soybeans. So make sure that when you change something and you get ready to blast, that you're not blasting something strange that's not supposed to be there. And it says right here, parameters that are different are marked with yellow. So this is a word size. The word size is pretty small. And then this is what you're looking at, what you're comparing it to. There are a couple of different versions that you can compare to. And it does change what you're expecting to see back. Somebody back in the dawn of time when they were first doing sequencing, some lady sat down and was reading through all of these protein sequences, all this, and kept seeing similar motifs. And she came up with this system of comparing things to each other, and these blossoms are the results of her work. And I can't remember her name off the top of my head. But when you change this, your results will change. So be aware that mucking with this changes your results. Yeah, there's a ranking that you can see, and I don't have any. Let's see if I can find. Let's do. I worked on tax for a while, so that's always the gene that pops to my head. And then I can get to RefSeqs. I can get to my protein. Yes, maybe here. Can I run my blast directly from here? I can run blast. Yay! Okay. So I'm not going to change. Did I change anything? Nope. I'm just going to run a generalized blast. Running. And it takes a while. It will sit here for a while. You can run blast Ps with the limitation that you only want to see things that have X-ray crystallography structures or like solved structures as well. That's in You know how like when you're thinking of something and it just like runs away? Hi, we're teaching right now. You can come back in like half an hour-ish. But yeah, you can qualify in BLASTP specifically that you want to be able to see only results that have a corresponding solved structure. So that's a really nice way of being able to refine your search. So I think what you're talking about is, am I down here? Am I showing it properly? Hello. Where did those scores go? I might have it formatted funky. It might be in search summary. I don't know what. Let's see. Yep, those are your scores that you're winning. And it's on the far end of my screen that I can't see. Yep, they're all, there they are. Your e-value, your max score, your total score, your query cover. So those are really nice to have if you want a really good search. You need it to be within a certain range.
That number is compared to whatever you put in.
Yeah, whatever you put in as your BLOSSOM reference, it's compared to that. And you can, it didn't do that, what I wanted it to do for that. You can do related structures. So if you have, this one's not related to a whole lot of other things, but if you wanted to find related structures, you can do related structure search. Mine up at the very top, there's a related structures, distance tree taxonomy, multiple alignments. Those are all options. It's optional. I don't know why it's not working. Smart Blast. Oh man. They've come up with something new. Sorry. Lovely. That'll be fun when I figure out what it is. It looks like it's just the same type of thing, but a little bit different. It's got a little bit, it tells you the family tree to start with. It's got your best hits, additional blast hits, and then your sequences. You can see there are related information. So if there's identical proteins or some other information, there is that information in the larger, for each sequence, there's this little box of info. Fun times. Protein search. Include, where did that go? There's a place to select you can align sequences if you want to do that. Compare two different sequences. It's just a radio button. This lovely little radio button here. So if you have two sequences and you want to see the similarity between them, it's a really fast, just like, let's click here, and it shows you the two different sequences. It's a nice feature to have. I'm trying to remember where the models I can't find where that particular aspect is at. But yeah, you can limit your search. I think it's part of your, this is where it is. You can limit a search query and create limit to, and then say link out to, and then the database that the protein structures are in, and it will limit it to that. If you want, I will give you more information on that. I can send you that information. So, but you can add additional information. So if you want it to be part of a particular organism and you didn't start it at the top, or if you want it to be, whatever you normally search in the databases, you can put those same search qualifications in here, and you can do that. One other thing I want to show you outside of BLAST, because BLAST can take up like an entire lifetime. Whenever you're searching, wherever you search, I'm going to do PubMed because I like PubMed because it's what I live in most of the time. Okay, you do a normal search, great, it's all right. So when you come to any search, advanced search, you have the option to change where you're looking for things, and that's really nice. And there's this great button over here. So you choose a field and you hit the show index, and it tells you what's indexed in, what those index terms are that are available for that. So if you're looking for a gene and you want it to be on exon 4, and you put 4 in exons in the exon field, it doesn't come back with what you think it should. It's because it didn't get indexed the way that you're writing it. Because the people at NCBI don't think like you. They think a little bit like you, but not exactly like you. They're a lot more specific. So, and you can start typing. So if I want to link out provider, I redo my index, and I'm closer to where I want to be. Link out provider. So you can choose, and it has to be in the right thing, otherwise it isn't happy. So I showed you link outs before. You can search here for link outs, and I want to do Dryad. Let's see. So this is the Dryad database. So I hit add to history or search. I like to add things to history because I'm lazy, and then I can add them back to my search later. So I'm now searching things that are linked to Dryad and have celiac in them someplace. And when I do my search, then I get my results. And this is the one thing in Dryad that has celiac associated with it. So you can do that for any database. So when you go to, let's go to gene. I like gene. Gene's an easy one to work with. So when you go to gene and you go to an advanced search, and you choose exon count. You're looking for a particular type of thing and you want only so many exons. If you show the index here, this is how they label them. It doesn't make any sense, and all those zeros are required to actually find what you want. So if you're not finding what you think you should be finding, do a search like this. Figure out which field you're searching. Everything in the records are arranged by fields. It will have a field label, and then it will tell you what that thing is. Search by the field, put the field thing in, hit the search index, expand index, or show index, what it's called, show index. And it will show you how that information has been input into the system to keep it straight. Thanks for coming.
Thank you very much.
You're welcome. So you can do searches. So if you want a gene with only so many exons and you want it in a particular organism and you want it to have a particular effect, you can do those in-depth searches very easily. Sure.
Like you said here, find the gene, right?
Mm-hmm.
And then you have a gene.
Your gene is over there. Yep.
Where did you get the sequence like?
Where did I get the sequence? Okay. The sequences, the reference sequences are all listed under reference sequences. So if you go there, this is your genomic, this is your mRNA and your protein. They assume mRNA and protein are the same thing because they're strange. They don't actually record mRNA.
So they need mRNA protein, like protein.
Right. You have to have mRNA to make protein.
And then you blasted it, right? Directly from here.
Yep, you can blast from this, either the GenBank Fast Sequence Viewer, either any of those. When you click on it, you can just, on the top right-hand side, there will be a way.
Blast that particular gene, right?
Yep, that particular gene sequence. It gives you a range when you
So
hit
if
black.
if I have my own gene sequence, how do I do this?
If you have your own gene sequence, you can just copy and paste your gene sequence right into BLAST and blast it and compare it to whatever shows up. So if you've run your sequencer and you get your results back, you should be able to import into BLAST directly. You can download a file into it, you can copy and paste.
Yeah, so this is the gene, right?
Yep, that's your sequence, that's your protein sequence
So
there.
if I want to blast from here,
If you want to blast from here, you can go up here, up to the top, and there's a run blast link. And it's looking at it. See, this is your reference sequence, and this tells you which amino acids are you're looking at for the sequence.
okay. Thanks, that helped. Yeah.
Okay. Any other questions? I'll let you play for a little while. I'll stick around for like half an hour. If you have any questions, let me know. I never know quite what to cover because it's. Yep, it's fun. Thanks for coming. If you have any questions in the future, let me know.